Welcome to myprojectbazaar.com. Our product title is High Performance Pipeline Architecture of Elliptic Curve Scalar Multiplication over GF to power M. Next we see about abstract of our product. Generally the digital architecture is mainly used in all type of real world applications architectures, and thus the architecture to modify based on the enhancement purpose. The VLSI technology is to optimize the any type of digital architecture. The main objective is reducing the processing delay in the crypto system. Elliptic curve scalar multiplication is the key operation which dominate the performance of elliptic curve crypto systems. To improve the working frequency and to reduce the required number of clock cycles in elliptic curve scalar multiplication, finite fields are algebraic structures that are used in error correcting coding in cryptography and digital signal processing. It can successfully be applied to polynomial multiplication. The KOA can be applied recursively to the 3 polynomial multiplication. It is considered as one of the fastest way to multiply long numbers. For polynomial multiplication with original KOA method, both operands have to be divided into two equal parts. Field multiplication can be performed in two steps. First one, we perform an ordinary polynomial multiplication of two field elements. Second one, a reduction operation with irreducible polynomial is needed to be performed in order to obtain the n-1 degree polynomial. Next we see about flow diagram of our product. In this flow diagram, first that address data is fed into the finite state machine. Finite state machine is nothing but the system to be designed is a very simple one, and its purpose is to introduce the idea of converting a FSM. This FSM has 4 states A, B, C and D. The system has one input signal called B, and the value of B determines what state the system moves to next. The system changes state from A to B, B to C and C to D as long as input P is high. If P is low and the system is in state A, B or C, the state is not changed. If the system is in state D, it changes to B if P is high and to A. If P is low, the system also has an output called R, and that address data is fed to the register bank through the control room, and the control room is nothing but the room is read-only memory. It is used to store in data, and it can only be modified slowly, and it is not all. It is mainly used to store framework in a data, and the data is fed into the finite field multiplier accumulator control signals, and also in the register bank the input data is stored. That input data is split into two datas. That data is fed to the finite field multiplier accumulator. Another one is fed into the finite field squarer. In the finite field multiplier accumulator having several blocks such as multiplexers, adder, multiplier. After processing, the data is again fed into the register bank, and same process is done in the finite field squarer. The data is again fed into the register bank. If the data is getting from the output data from our requirement. Next we see about the running process of our product. Our product is done in Xilinx 14.2 version. First open the Xilinx software, then the window is open, and create the new project file and give the project file name. This is the file name ECSM. In our product, the file name is ECSM. That means elliptic curve scalar multiplication. And then the coding is generated. After that, the simulation is running in the corresponding ISE simulated window. This is the simulator window. The data was given. First clock reset enable selections or the control logic signals, and start is a address. That address is given from the final state machine, and P10 XB0 RM0 are the input of multiplexer in the finite field multiplier accumulator, and MR is the output getting from the multiplier accumulator, and SR is the finite field squarer output. Then the output is corresponding output is displayed here, and this is one part of the output. Another part of the output is the utilization of devices and timing and also power. Next we see the output of devices and timing summaries, and here the device summaries is here. The device utilization summary, the LUT values are given here, and also flip-flop value is given. In our product, the LUT values is 444 and the flip-flop value is 372, and input output of bounded value is 49. And next to see the timing summary of our product. In our product, the total bath delay is 6.45 nanosecond. This is our record time, and this area is reduced compared to the conventional products.